Hey everyone, we're going to be talking about section 9.3 on acceleration. So acceleration is a motion that talks about the velocity and how velocity is changing. And remember, velocity is about speed and direction. So if either of those things change, we have acceleration. So a change in speed or direction is acceleration. Anytime the speed of an object changes, the object experiences acceleration. So it can speed up or it can slow down. And if it's a decrease in acceleration, meaning it slows down, that's called deceleration or negative acceleration. And let's say we're going the same speed somehow, but we're changing direction. Then it is also accelerating, even if it's moving at a constant speed, because it is changing direction. So an example of this would be a circular motion, much like the moon going around the Earth. It's going at a constant speed around the Earth, but because it's constantly changing direction, orbiting the Earth, then it is accelerating. A car moving around a curve or changing lanes at a constant speed is accelerating because it's also changing direction. So when we calculate acceleration, you are going to take the final velocity, so the speed and direction at which it ends at, minus the speed and direction where it started at, the initial velocity, all divided by the time. So if velocity is measured in meters per second and time is measured in seconds, the units you're going to have, it's called meters per second. And it can also be written right here as meters per second squared. Because remember, up here is meters per second, down here is seconds, so meters per second. So looking at this example, it says that you have a roller coaster starts a downhill slope, and its velocity is 4 meters per second, but 3 seconds later, its velocity is 22 meters per second. So what is its acceleration? So you can think of a roller coaster going downhill. It's going to speed up. We know that. So the initial velocity is this. This is where it started at, 4 meters per second. The final velocity is this, 22 meters per second. And that was all over 3 seconds. So the way you would set it up is just like this. You take the formula, final velocity minus initial velocity divided by time, plug in your numbers, 22 minus 4, that answer divided by 3. So 22 minus 4 is 18. 18 divided by 3 is 6, so it's going to be 6 meters per second squared. So the acceleration is 6 meters per second squared, and you have to give it that direction, down the slope. And you have to ask yourself, does it make sense? If the car's velocity increases by 6 meters per second for every second, its velocity is going to be 10 meters after 1 second, 16 meters after 2 seconds, and 22 meters after 3 seconds. So that should make sense. So what graphs are going to be used to analyze motion? Before, remember, we always had a distance time graph, much like this one over here, and it was a straight line that meant constant speed. Now this is a distance time graph, and it actually showing that it's speeding up here and here and here, because think of these as little increments of slope, and it's getting faster and faster and faster and faster each time here. So you're going to see that the speed, this is getting faster as it goes right up that arc. The other kind of speed you can use for acceleration is speed on the y-axis and time on the x-axis. And the slope of a speed time graph is acceleration, because remember, this is meters per second. So it's speed over time, change in speed over time, which is the definition of acceleration. So this is showing that something is accelerating at a very constant rate. And that's it.